Hey everyone! A few weeks ago, I did a video on how to measure the speed of sound with an Arduino. I'll be using it on my high altitude balloon project. But the next challenge was to figure out how to mount this to my flight computer frame and an Arduino and have a stable target so that it gets accurate measurements while it's in flight. I decided to play around with EagleCAD. It's really easy to use EagleCAD. If you haven't tried it yet, you gotta try it. It's free. You pretty much get a template for an Arduino, Raspberry Pi, whatever you're working with, and drag your components into place. The ultrasonic rangefinder will go in these holes back here. I'll have a target set up over here, and it's all mounted to the Arduino using these little header pins. I found these a lot easier to solder than the male to female ones. They just snap apart. You can see the little perforations on there. They break apart pretty easy. And then I actually soldered it using while it was attached to the Arduino itself, so it was very easy to do. And then these holes down here at, this side, that's where the altimeter will hook up, and we'll have a target attached down here at this end so that we can get our speed of sound measurements while it's in flight. So let's look at this. This is the finished product. You can see it's all soldered and attached. Worked out pretty well. I've got a card attached right here. Right now it's just hooked on with some poster putty, but I'll be using hot glue or something like that when it's finally ready to go. And then I've got the altimeter right here hooked up to the custom designed shield for the Arduino Mega. So let's go over to the computer. We'll take a look at the code for this thing again. I won't get into it in too much detail, but I did have to make some changes because there was a mistake on this thing here. I don't know if you can see the traces on this, but these middle two are the trigger and the echo pins, and I actually sent them over here to the analog side. But no problem. Let's go over to the computer and I'll show you how to make that work with the analog pins. Alright, so here's the Arduino code. I'm not going to go over this in detail. If you want to see how this all works, go check it out. It was a video from about 3 weeks ago. But the biggest change right here, when you're defining your pins with the analog pins, if you put the A in front of it there, the Arduino actually treats it as a digital pin. So we'll still get PWM, and it still works. We've got the altimeter all set up here. We're going to output the altitude in feet, air pressure in pascals, temperature in Fahrenheit, and then we'll calculate the speed of sound. The card is approximately 5 centimeters away, so 10 centimeters right here for the round trip. So that should work just fine. Let's go ahead and plug this in. You should see something pop up over here on the serial monitor. There it goes. We're getting altitude, air pressure, temperature, and speed of sound right around 340 meters per second, so everything's working perfectly. Let's take it over to the Pi and make sure it works with the logging application that I did last week. Alright, so over here I've got the Python code that I wrote last week. If you want to see that in detail, go check out the video from last week. I'm not going to go through this in complete detail. There's a lot of stuff here. But I just want to go down here. You can see that I've altered the code down here so that it will only give us a stream of data and not run the part with it being landed. So let's go over here to our putty terminal and run the code. Should get a long stream of data here. There we go. We can see all the SenseHat data. We can see the altimeter data and the speed of sound data. We'll let this run for a little bit, and then we'll check the CSV file to make sure that everything worked properly. Okay, that should be good. Let's just jump over here real quick. Check out the data CSV file. look at all that. All right, so we've got 15 lines. Here's what we were really interested in. We got CPU temperature, we've got altitude, air pressure, external temperature, speed of sound, and timestamp. Perfect. Then we want to take a look here. We've got our video file. We should have gotten a few megabytes, 67 megabytes of 1080p video. So everything seems to be working just fine. I think that wraps up everything that needs to be done with this. We're ready for some large-scale testing. Next week, I want to put everything in a box full of dry ice to see how it holds up in extremely cold temperatures. That's really just going to be more of a worst case scenario. It's all going to be insulated in a styrofoam box, so I don't anticipate it actually getting that cold. But if it were to get that cold, how would it hold up? So that's what we'll be doing next week. Make sure you hit subscribe, give the video a thumbs up if you liked it, and I'll talk to y'all next week. Thanks.